Welcome back. So all this data modeling stuff we've been doing so far looks pretty cool, but it doesn't seem to have gotten us a lot closer to our holy grail of combining multiple data sets into a single power pivot table. But actually, it has. We've been setting ourselves up for success all this time by establishing relationships between tables that will allow us to combine those tables in one pivot table with ease. So let's see how that works. So the whole point of all this data modeling is really to be able to mash these different data sets together in a power pivot table. Now when I say power pivot table, I really just mean a pivot table, but one whose data source is the Excel data model. Now we built a very simple one a couple videos ago, but without the benefit of a deep understanding of how the data model was supporting that. So now we're going to build a slightly more complex example with the structure of our data model clearly in mind. So first, as with our other example, I'll just go to our Insert tab to insert a pivot table like we would any other pivot table. And Excel is defaulting for our data source to be the workbook's data model, which is what we want. So we'll go ahead and click OK. And now to see the list of fields we have to choose from a little bit more clearly, I'm going to hit this gear icon in our pivot table fields list and then choose a different layout, that being fields section only. So now I have a much clearer idea of all the data I have to choose from for my pivot table. And as you can see, it looks like we have all the fields in all the tables we've added so far. Now there's a little bit more nuance than meets the eye here that I won't fully explore in this video, but suffice it to say that all of these tables aren't necessarily compatible with all the others in a single pivot table. Think back to our chains of one-to-many relationships in our data model. Basically, any tables that are part of one of those chains can be used in a single pivot table. But two tables that are part of entirely different chains of one-to-many relationships cannot be used in the same power pivot table, at least meaningfully. So it's enough for you to understand now that while I can use the products table and the orders tables in a pivot table with the order details table, it won't help us if we try to use the products table and the orders table together in a pivot table without having that order details table there as something they both relate to. Now we'll explore this phenomenon in much more detail in a later video. But for now, let's get busy building our pivot table. So what we'll do to start is break down the count of our customer orders by customer ID. So first I'll go back to my default view in the pivot table field list, and then I'll drag my customer ID field from the customers table down to the rows area, and then I'll find my orders table in the fields list, and I'll drag my sales order ID field from the orders table to the values area. And then I'll change the calculation method to count. So now we have a quick breakout of count of customer orders by customer ID. Now this pattern, in which fields from a lookup table like the customers table go in either the rows area or the columns area, and fields from a data table like the orders table go in the values area, is very, very common. But as with so many things in data modeling, not universal. Just keep that in mind. So as it is, our pivot table is a little blah, but because of the relationships we've already formed in the data model, we can add new layers to our rows area just by dragging in fields from different tables. So for example, we can drag in the name of the state that each customer is a resident of as another label in our row area. So we'll find our states table and then just drag in state name directly above customer ID. And now if we collapse that level of the hierarchy in our pivot table by choosing expand collapse and then collapse entire field, now we have a count of customer orders by state. And we don't have to stop there. We can also go to our regions table and then drag in the name of the region that each state belongs to. Now this underlines another very common pattern when building pivot tables from tables in a data model. Tables on the higher end of the chain of one-to-many relationships, or in the orientation that we chose on the leftmost side, tend to be at the top level of the fields in either the rows area or the columns area. So basically our pivot tables flow just like our data models. You start with regions, then states, then customers, then orders. And if we go back to our pivot, we see that we have regions on top, then states, and then if we drill into an individual state, our customer ID. Now, another great thing that the data model gives us is the option to pull out an intermediate step in that chain of relationships if we just don't need to see the data from that table. So for example, if we decide that this customer level breakout really isn't meaningful to us, and we only want to see a breakout by region and state, we don't even need the customer ID field in our pivot table for the pivot table to still give us these accurate breakdowns. So first, let's keep an eye on one number in our pivot table. Let's say the count of sales order ID for Kentucky, which is 310. Now let's go down to our pivot table field list in the rows area and remove customer ID from rows. So now customer ID is gone, but our count for Kentucky is unchanged. And again, that's possible because even though our state and region tables aren't directly related to our orders table, they are connected to it via a one-to-many relationship through the customers table. Now, just like with a standard pivot table, if I double-click one of the numbers in this pivot table, Excel actually creates a new worksheet with detailed data behind the number that we double-clicked. And if we scroll down all the way to the bottom, we see that there are 310 rows, the same number that we saw in the pivot table. Now, I also want to point out that the fields that we see in this generated detail extract all come from the table that we are applying the sum or count to in the values area of our pivot table. Now we're doing a count of sales order ID from the orders table, so in our generated detail data, we get the 4 fields from the orders table. Now the process by which Excel generated that extract may seem magical, but actually it's the outcome of something called filter context. So you can think of filter context as the intersection of all of the different groupings or filters that apply to any given number in our pivot table here. That number is the result of applying 2 filters. One is the state associated with a given record must be Kentucky, and 2 is that the region associated with a record must be East, South, Central. And this concept continues to apply no matter how many levels of grouping we have in our pivot tables, if we have column groupings, row groupings, or even filters in the filter section. For example, let's say I wanted to be able to filter my pivot table for all customers who are either loyalty club members or who are not. So if I expand my customers table, I'll see a field called loyalty club member. Now if I drag that into my filters area, now I have that available as a filter in my pivot. So if I click this filter and then expand and select a 1 and then click OK, now my Kentucky number has changed to 116. And that's a result of a 3rd filter being applied to that particular area of the pivot. State equals Kentucky, region equals East, South, Central, and loyalty club member equals 1. Now if you navigate to different levels within the pivot table, different filter contexts apply. So to make this clear, let's go ahead and add subtotals to our pivot by going to the Design tab, Subtotals, and then Show All Subtotals at top of group. So now we see a breakdown of count of sales order ID by region in addition to state. So if we look at this 411 number for the East, South, Central region, there are actually only 2 filters being applied here. Our loyalty club member filter that applies to everything in the pivot table, and then the region filter for East, South, Central. But the state filter does not apply because this number is at a higher level in that hierarchy of the pivot table. You can think of each of these numbers in the values area as having a kind of address. And that address is at the intersection of all the filters that apply to that particular number in the pivot. And those filters are what determine the rows in our data that we are applying our count or sum or average or what have you over. So before we go, let's add just a little bit more nuance to our example. Now, as I mentioned briefly before, while the most common scenario is for lookup tables to relate to data tables can also relate to data tables if there is a one-to-many relationship between them. Again, if we look back at our data model, we'll see that our orders table, which by most standards would qualify as a data table and we're actually using as a data table in our current pivot table, relates to our order details table in a one-to-many fashion. So with that said, let's throw in a count of items ordered and not just a count of orders into our pivot table. So I'll expand our order details table and then drag in sales order detail ID from that table and make sure to summarize that by count. And then just so we can see our grand total more easily, I'll select the regions level of our pivot table, right-click, expand collapse, and collapse entire field. And then to make the grand totals crystal clear, I'll also remove this filter for a loyalty club member. And we see that our grand total order count is 30,500, and our grand total item count, that is all the items that were included in all those orders, is 71,207. Now if we go back to our data model, and then look at the data model in the data view, and then look at our order details table, it says at the bottom left that our order details table has 71,207 records. And then if we look at our orders table, it looks like it has 30,500 records. So the bottom line is, our pivot table was able to include accurate counts from both of these tables. Now, while this may not seem all that revolutionary, think about how this process might look if you were trying to combine these data sets into a single pivot table without the use of the data model. Most likely, you would end up using either a VLOOKUP, or if you're comfortable with Power Query, a merge query, to pull our orders data into our order details data. That's because our order details data has a higher level of detail with the potential of multiple copies of any given order ID. So imagine we have to VLOOKUP our orders data here into our order details data set. And then after taking that step, we try to pull that mashed together data set into a single pivot. Well, the problem is our overall record count in our new data set is going to be 71,207, the number of records in our order details table. So regardless of which field we apply a count to in our modified combined table, we're going to return the same number. So our grand total number for sales order detail ID or sales order ID would still be 71,207. So aside from the convenience of not having to go through all that trouble of combining two datasets together, this is just another example of the power of the Excel data model combined with pivot tables. All right. Up next, we'll work on adding a specialized type of lookup table to our data model called a calendar table. I'll see you then.